Welcome back, students. This is the Q&A session 13 from the playlist of friction. The topic is the friction between the stack of 3 blocks. The question for this session is written here on this board, and this is the figure which was provided along with this question. So in this figure we can see that there are 3 blocks which are lying one over the other. This 30 kg block is resting on a horizontal surface whose coefficient of friction is 0, means this is a frictionless surface. This 20 kg block is lying over this 30 kg block, and this 10 kg block is lying over this 20 kg block. Now the coefficient of friction at the interface of 20 kg and this 30 kg is 0.25, and the coefficient of friction between at the interface of 10 kg and 20 kg block is 0.5. Now in this question, a 100 Newton force is applied in the horizontal direction as indicated by this arrow to this 10 kg block. So in this case we have to find the acceleration of the block 20 kg. So here we can see that the external force is applied only to this 10 kg block. So when this external force is applied to this 10 kg block, then this 10 kg block will have a tendency to move in this direction, that is in the direction of the applied force. So since the coefficient of friction here is 0.5, it means that this is a rough surface. So the force of friction will oppose the relative motion, and as a result of it, the force of friction, the direction of the force of friction for this 10 kg block will be as indicated by this arrow, and that is denoted by Fs1. So the force of friction which will be acting on this block will be directed in this direction, and now this 20 kg block is being subjected to this force of friction. Now the most important thing here is that when we apply this 100 Newton force to this 10 kg block, then this block has a tendency to move in this direction, and when this block has a tendency to move in this direction, then this 20 kg block will be left behind. Now the force of friction opposes the relative motion, and it will try to move both these blocks together. So as a result of it, this force of friction which was acting in this direction, that is in the direction opposite to the direction of this applied force, will be acting in the forward direction, that is in the direction of this force for this block of 20 kg, because the force of friction will try to move these two blocks together. So on the application of this external force of 100 Newton on this 10 kg block, the force of friction for this 10 kg block will be acting in this backward direction, whereas the same force of friction will be acting in the forward direction, so that because the force of friction always tries to move the blocks together, or in other words we can also say that the force of friction opposes the relative motion. So for this 20 kg block, the force of friction will be acting in the forward direction. Now let's come to this surface, this interface. Now here this is the surface where this force of friction this coefficient of friction is given as 0.25. So now let us first of all find the value of this force of friction at the interface of 10 and 20 kg block. So this is equal to 0.5. It is the force of friction is given by mu n. So the value of mu is 0.5, and n is the normal reaction. Now the normal reaction is basically equal to the weight. Now here at this surface, that is at this interface, the normal reaction will be equal to, m into g, and here m will be equal to 10 kg. at this surface. So the value of G in this question is to be taken as 10 meter per second square. So I have taken the value of G as 10 meter per second square. So the force of friction is equal to 50 newtons. Now this force of friction will be acting in this backward direction for this block of 10 kg, and the same force of friction will be acting in the forward direction for this 20 kg block. Now let us calculate the magnitude of the force of friction at this interface. So let us at the interface of 20 kg and 30 kg. So let us denote that force of friction as Fs2. This will be equal to 0.25. Now in this case the normal reaction, as you know, that this is equal to m into g. So at this for this interface the value of m will be equal to 20 plus 10, that is equal to 30, and the value of g is 10, so this is equal to 75 newtons. So the value of the force of friction, that is Fs1, is equal to 50 newtons, and the value of the force of friction, that is Fs2, is equal to 70 newton. Now this is the Fs1 is the force of friction at the interface of this 10 and 20 kg block, and Fs2 is the force of friction at the interface of 20 and 30 kg block. Now here we can see that this Fs2 is greater than Fs1. That is, the force of friction at this interface, at the interface of 20 and 30 kg, is more than the this force of friction at the interface of 10 and 20 kg. So because of this, these two blocks will not have any relative motion. There will not be any relative motion between these two blocks, and these two blocks will move together. So when these two blocks will move together, so we can consider this as one block of 50 kg. So the force which will be acting on this one block of 50 kg will be this force of friction, that is Fs1. So this Fs1, it will produce the acceleration in the single block of 50 kg, that is 20 kg plus 30 kg. So we have taken this as a single block of 50 kg because there will not be any relative motion between these two blocks, because the force of the friction at the interface of 20 and 30 kg is more than the force of friction at the interface of 10 kg and 20 kg. So it's been all very simple. It implies that the acceleration of this 50 kg block will be equal to the force of friction which is acting on this block in the direction of this applied force, and divided by the total mass. So this is equal to Fs1 is equal to 50 newtons, and here the mass is also equal to 50 kg. So the acceleration, you can say, of this 50 kg block will be equal to 1 meter per second square, or we can say that the acceleration of this 20 kg block will be 1 meter per second square, and the acceleration of this 30 kg block will also be 1 meter per second square. So thank you very much for joining this session, and in the next session I will be coming up with a different type of a question, but the topic will remain the same, that is the friction between the stacked objects. Till then, have a nice day. Bye.